In this video, I'll show you some examples of various equations, like solving for f, that involve, and inequalities, that involve exponential or logarithmic expressions. The first one is something like this. 2 to the 2x minus 12 times 2 to the x plus 32 equals 0. This might have up to 2 answers. And the trick to this question is to notice that 2 to the x to the second power is equal to 2 to the 2x. You raise a power to a power by multiplying the exponents. So, if I replace, sometimes I like to say, make a new variable called u is 2 to the x. That would turn this into a u, and this 2 to the 2x would turn into a u squared. So the way to recognize this is if these bases are the same, the 2's, and if this exponent is double the exponent on the other one, you have this going on. It turns into this, a quadratic equation. So you factor it. So u equals 4 or u equals 8. But the u, remember, was 2 to the x. So this has turned into now 2 different exponential equations which have answers of 2 or 3. So that's one question that I like. If I want to make it more difficult, here I have 3 to the 2x minus 2 times 3, not to the x, but to the x plus 1. This plus 1 makes the question a lot harder, or harder to get started. Once we get past the first step, it becomes the same thing as the other question. There's a rule in exponents, like a squared times a to the third equals a to the fifth. You add the exponents together when you multiply things with the same base. Well, you could also go in the other direction. Like if I have a to the x plus 2, I could split it up into a to the x times a squared. And that's exactly what I'm going to do over here. I'm going to leave the 3 to the 2x alone. And this 3 to the x plus 1 I'm going to write as 3 to the x times 3 to the 1. And this 3 to the 1 I can combine with 2, and it turns into 3 to the 2x minus 6 times 3 to the x minus 7 equals 0. If I let u be 3 to the x power, this becomes u squared minus 6u minus 7 equals 0. Sometimes you might have to use the quadratic formula. Not this time. U plus 1. And I get u equals 7 or u equals negative 1. Now that u was 3 to the x, so 3 to the x equals 7 or 3 to the x equals minus 1. Now 3 to the x can't equal minus 1 because when you raise 3 to any power, it becomes positive. So all that's left is this one. And I'll just say, we have to use log, so x ends up becoming log base 3 of 7. If I have a calculator, I could do it, or I could even do log base 7 over log base 10 of 7 over log base 10 of 3, and I get an answer of about 1.77. That's the only answer to that question. A basic exponential equation, something like this, has an answer of x equals 3. 2 to the third does equal 8. And if you want to do it sort of algebraically, what you can do is you can take the log base 2 of both sides. And log base 2 of 8 is 3. And log base 2 of 2 to the x That's x, because it's log base 2 of something is what power would I need to raise it to become that number. So what do I need to raise 2 to become 2 to the x? The answer is x, just like log base 2 of 2 to the 17th should be 17, because you would have to raise 2 to the 17th power to become 2 to the 17th. Now if I change the equal sign to a greater than sign, we can do the same process. We can do the log base 2 of both sides. And we end up with x on the left and 3 on the right. But it gets a little more complicated than that. Here's a question: 1/2 to the x is greater than 8. And we can't quite do the same thing as before. Remember back in algebra when you learned solving an algebra equation, you could divide, solving an algebra inequality, you could divide both sides. But if you were dividing both sides by a negative, you would have to switch the direction of the inequality sign. Well, something similar happens with these exponential equations. And the reason why that is because if we take a true statement like 4 is greater than 2, I can do algebra, like add stuff to both sides, and it's still going to be true. 4 plus 1 is bigger than 2 plus 1. If I do the log of whatever base, in this case base 2 of both sides, it seems like it's still going to be true. Log base 2 of 4 is 2. Log base 2 of 2 is 1. So it seems like I can just take the log of both sides and keep the equality sign, keep the inequality sign in the same direction. But it actually depends on what base I use. Because while it is true that 4 is greater than 2, and it's true that log base 2 of 4 is greater than log base 2 of 2, it's not true that log base 1/2 of 4, when I compare it to log base 1/2 of 2, log base 1/2 of 2 is negative 1, log base 1/2 of 4 is negative 2, and it turns out that when the base is between 0 and 1, you would have to reverse the direction of the inequality sign to make it true. So when I come back over here, if I say log base 1/2 of 1/2 to the x, I would have to switch the direction of the sign. Log base 1/2 of 8, and I would get x is less than negative 3, not x is greater than negative 3. So that's like a thing to watch out for when you're solving log exponential inequalities. You have to change the direction of the sign when the base is between 0 and 1. Before I do log inequalities, I want to do a quick review of log equalities. So here's a question: log base 4 of x plus 2 is equal to 3. One way to do a question like this is to just rearrange. Remember, if log base b of a is equal to c, then b to the c equals a. Those are like equivalent things. So if I see an expression like this, I can just rearrange it as 4 to the 3 equals x plus 2. 64 equals x plus 2. X equals 62. But there's another way to do that that's going to be maybe more useful for the inequalities that are coming. Instead of doing that thing where I rearrange, because when I rearrange, it's not that clear what side I should put which thing on, but it doesn't matter either because it's just an equal sign between them. So another way to do it is to stick a giant 4 here and a giant 4 there. So 4 raised to the log base 4 of x plus 2 is just x plus 2. And 4 raised to the third is 64. So we end up at the same equation, but a bit of a different way. The reason this is true, it's like 4 to the log base 4 of 75 has to be 75. Log base 4 of 75 is 3 point something. And if it really is log base 4 of 75, when I raise 4 to that power, I should get 75, and I do. So this method of sticking the giant 4 there, we have to be a little careful, because yes, 4 is bigger than 2, and if I raise 10 to the power of 4, it's bigger than 10 to the power of 2, so that's true. But if I raise 1/2 to the 4th power, it's actually less than 1/2 squared. So if I'm going to take a number and raise both sides to that, make those the powers, raise a number to each of these powers that are on the left and right hand side of the inequality, if the base that I'm raising to a power is less than 1, we have to change the direction of the inequality sign. Here's a refresher of 2 more equalities. I just want to refresh for you something from Algebra 2. I should have done all the equalities before talking about inequalities, but I'll come back to those. This one you might be tempted to try to raise everything to rearrange stuff, but the best way to do this question is to first use one of the log rules. There's a log rule that log of something plus log of something else, if they have the same base, is the log of the product of the two things. Now, with an equality, no problem, I could just rearrange. This 4 ends up becoming the base, this 3 becomes the exponent, and this thing becomes the thing on the other side of the equal sign. It's an equal sign, so we don't have to worry about which side goes where. This becomes 64 equals x squared plus 16x plus 28, which after I subtract 64 from both sides becomes x squared plus 16x minus 36, which actually factors to x plus 18, x minus 2. And it seems like there's 2 answers, negative 18 and 2. However, yes, negative 18 and 2 might make this equation true, but it doesn't necessarily make this equation true or this one. And the way so what I'm getting is that we might need to reject one or both of these answers, and the way you tell which one to reject is you check to see if any of these answers, negative 18 and 2, make any of these things in the parentheses negative. And since negative 18 makes this and this negative, or even if it was just 1, we eliminate it. Now 2 doesn't make either of those things negative, so we keep it, and the answer is just x equals 2. If that plus was a minus sign, log base 3 x plus 7 minus log base 3 of x minus 17 equals 2, it's actually easier. The rule is if you subtract 2 logs that have the same base, you create 1 log where we put the quotient, take the log of the quotient. Now I could do that rearranged thing, 3 to the second equals x plus 7 over x minus 17. This is 9. And I cross multiply and eventually solve and get x equals 20. I should check to make sure, does 20 make either of these negative? And the answer is it doesn't, so that is the answer. Okay, now let's get to the inequalities. Log base 5 of 2x minus 1 is less than or equal to 1. I don't want to just rearrange the 5, the 1, and the 2x minus 1 because I don't know what side to put the 5 to the 1 on and what side to put the 2x minus 1 on. So instead, I'm going to do this thing where I put a big 5 here and here. Because 5 is bigger than 1, I do not change the direction of the inequality sign. And 5 to the log base 5 of 2x minus 1 is 2x minus 1. And I add 1 to both sides. 2x is less than or equal to 6, and x is less than or equal to 3. And it seems like we're done. But remember when we checked before when there were two potential answers and one of them got rejected? Well, this x is less than or equal to 3 is an infinite number of potential answers, everything less than or equal to 3. But there are some values that will make the thing in the parentheses negative. So on the side, I'm just going to say, when is 2x minus 1 positive? Well, I solve this little inequality and get x is bigger than 1/2. So the numbers I pick have to be bigger than 1/2. Not all numbers less than 3, less than or equal to 3 are also bigger than 1/2. So I have to throw into my answer this extra thing. I'll call this a domain check. Very important. Okay. If it says ln instead, no problem. Stick a big E here and a big E there. You do not need to change the order of the sign, the direction, because E is bigger than 1. And I get 2 minus 3x is less than or equal to E. What's funny about this one is when I subtract 2 from both sides and then divide both sides by -3. I already changed. I didn't change the sign around, but now I'm going to need to because of that rule. So I get E minus 2, the rule of when you divide by a negative. So x is greater than E minus 2 over -3. However, we're not done with this one either, because numbers bigger than that, some of them are going to make this thing negative. So I also have to come here and say 2 minus 3x is greater than 0, minus 3x is greater than -2, or x is less than 2/3. Because again, this one had a negative that I divided by. So this answer is actually like that. And that's a pretty hard question. Okay, the final question of this video is a log inequality where the base is between 0 and 1. We put a big, actually I'll write this a separate thing, 1/2 raised to the log base 1/2 of x plus 3. This has to, the direction of the sign has to change when I'm raising both sides, or raising 1/2, which is between 0 and 1, to both sides. See that changed. And the left side becomes x plus 3, and the right side becomes 16. So x is less than or equal to 13. But no, we're not finished, because we also have to do the domain check. X plus 3 has to be greater than 0, so x has to be greater than -3, and that's why this is our answer. So that takes care of equalities and inequalities with logs and with exponential inequalities and log inequalities. Okay, so that was 19 minutes. I hope you liked that video.